All right, cool. So yeah, let's just go through the exercises because honestly, like this week, that's kind of like the easiest way because I think that case expressions aren't like super difficult. The hardest I think part is for people to understand the difference between simple and searched, which we will talk about because we're going to show a couple examples of each. But anyways, for the first one, it wants us to use it has this query here, which I'm just going to take and copy. And I always like to kind of do like a twofold thing. Grab it, open up a new file here in Visual Studio Code, just because whenever I copy from Canvas, I'm always leery of special characters. So we will get rid of those. All right, go. So here we are on Workbench. So the difference between a simple and a searched case is actually, this is a good example of how we're going to go over that. So, and we need a comma. There we go. So right now, this is actually a simple case statement. And the difference is it just has to do with like this little piece right here. What comes after the case statement? So if we go back here, it says rewrite the following query, which uses a simple case expression so that the same results are achieved using a searched case expression. So right now, this is simple because there's a variable after the case, which really means that like we don't, the reason why we have this is it saves a little bit of typing. But that's it. And ultimately, I honestly never use them because you always end up having to go and adjust these. And anyways, sometimes it's easier just to not. I only use it if it's like really simple stuff. Like, so for example, case flag, or let's say case bool flag, when one, then yes, when 0, then no, things like that. I'll use a simple one, but for anything more complicated, I don't. So anyways, how we change this is we can change basically just the way this is structured and add conditionals. So in a simple case, you'll notice that there's no like conditional here. Like we don't say equal to, less than, greater than, or anything like that. And that's because it assumes that because it's simple, this is all equal. But the minute we take out this, now all of a sudden it expects something. And so what we have to do is we have to say when name is equal to on all of these. We're just going to go ahead and plug this in. So when name is equal to all those, each one of those, then it assigns the appropriate language. Oh, and I guess I need to use Sequila. There we go. And just to reiterate, just to make sure that I'm not a liar. Case. So I might be doing some. So when we put in, so like if, for example, if we wanted to say, so like there's a couple different ways to do this. Like let's say we want to, let's combine the other ones because there's fewer of them. So if I put name here, well, let's start over from the beginning. So if I say case name, and let's say I want to combine these two, like, so I don't have like individual ones. So if I say Japanese or Mandarin, that way I can kind of just like get rid of that. And why that is still working is beyond me, honestly. Am I running the right one? Huh. Maybe that works. That honestly surprises me just a little bit. Let's try a different one because I know that there are some where they won't work. So if we say case, let's see, character set from language, select everything from language. All right, so we're going to use numbers. We're going to say select the name, and then we're going to do language ID. Then we're going to say case, but we want to put language ID. We say when language ID, or just got to put the number when greater than, so it looks like Japanese and Mandarin. Let's just say when greater than 3, then there we go. So there's certain limitations to the simple expression. Basically, like when we put the variable right after the case, there's certain things that we can't do. And many of those like can change. So like this one works, but like if we were to say, you know, like percent, you know, this one's not going to work now because there's certain things that won't allow this simple expression to use. Like it has to be very much like, I guess that's why they call it simple. It has to be simple. So when they say we want to change this, that's why really all we have to do is take away the name here on the variable and then run it. So basically, if there's a variable after the word case, between case and the first when, then we know it's simple. If it doesn't have a variable after the word case and it just goes straight into conditionals, then we know it's searched. And searched is probably way more common. So anyways, that's step 1. Let's keep moving so we can get to 3. All right. Rewrite the following query so that the result set contains a single row with 5 columns, one for each rating. So one of my favorite things actually that it blows my mind a little bit. I actually didn't know how to do this embarrassingly until, I don't know, like a couple of years after college. You know, I was always writing subqueries, which not that there's anything wrong with that, but this is just way better. So anyways, right now we have our ratings and our counts, and we just want to pivot that. So instead of having, you know, each rating be a row, we want each rating to be a column. And that's kind of the word for this, is we're going to pivot this result set. And we've probably all seen pivot tables inside of Excel and stuff like that. And that's essentially what we're going to do. So what we do instead is we say select, and, you know, we can, let's say we want to select, I'm just going to say select count of films as metric. We're going to make it pretty, I guess. And then we can do our same thing, but we're going to add a case statement. So I'm going to say count, but instead of just saying everything, I'm going to say case, and I'm old school. To be on the safe side, I'm going to say count distinct so we don't duplicate, which in this case is overkill, but it's just good to have it. whenever we're trying to count individual films. So I'm going to say count distinct case when rating is equal to G, then film ID end. And we can make it pretty. There's that. And now we're just going to take and just duplicate this over and over for each rating. So let's just go ahead and do that. PG. PG 13. It's just R and NC 17. And there we go. Now, so you can see basically what we're doing is we're counting individual film IDs, distinct film IDs, but we're limiting what goes into that count inside of it, which is pretty cool. So basically allows us to pivot it, and we even kind of give it a cool little name. Now, if we were just to take this out, we could just have it like this too, which works. All right.
Can I ask you a question about that?
Sure.
That you just did? The one thing about that using count that doesn't make sense to me is that you have the when, then doesn't make sense. You're saying then film ID, whereas, you know, in other places we've seen then is a string value or a numerical value, but here then is the column name or the, to me, that doesn't make sense why that works.
So let's take a look. So what I'm going to do is I'm going to select the film ID and the rating, and then I'm going to put our case statement here for G-rated movies. Now I'm just going to say from film. So basically what's happening, because we know that this is, and let's say as G, since that's our G-rated movies. So we can see what's happening here when we don't do our aggregation. So this works because we're only returning film ID for places where the rating is equal to G. So this is still like, you know, it just matches up whatever the film ID is. But you'll notice that for all the ones that aren't rated G, it's null. And so really what we're doing is we're taking advantage of the fact that the count function doesn't count nulls. So in the end, we end up with the number of unique films that have a rating of G.
So it's counting that column. Okay, that makes a little more sense. That is not the way my brain works, but okay.
Yeah, it's a little funny. It's kind of it's not necessarily a hack, but it kind of is. You know, like, so let's add another one just so we can kind of see, because, you know, we're going to be in different columns just like we wanted for the other one. But you'll see here that it's you know, this line is a PG rated movie and the G is null, but since it's PG, basically it just gets the same value. So it's the same as if we were going to like assign something else there. We just choose to use film ID because we want a unique value, so to speak. Like, for example, another way to do this is some people will literally just put a 1 there. So like instead of using the film ID, they'll just say 1 and then instead of doing a count, they'll sum it. I don't like that as much because it's not as accurate when you're trying to count distinct things, because there may be cases where the film is twice in there, which, depending on what you're looking for, may be what you want or may not be what you want. So you just got to be a little careful. But so if I were to do this, we get the same results, but this time instead of, counting things, we're just, if it's a G, we put a 1 there. And, if you really want to like be thorough, we can say else 0. And then we'll get like just we can sum them, because anything that we want to see will be a 1 and anything we don't want to see will be a 0. So then you can sum those to get your totals. It's the same concept, but with one we're counting and the other one we're summing. But I think this might make sense to more people, to kind of wrap our heads around it. Because every record may or may not have a value there, but yeah, depending on what the rating is, we decide what value we want to put there, and then from there we can count them or whatever.
Okay, I was happy to see you use count because I couldn't figure out what you would count, but yeah, your explanation makes sense.
Yeah, and that's why I like, especially when it comes to counting, like, and to me, like if I'm just counting the sheer number of rows, I use count. But if I want to count like individual films, like, oh, how many films are rated G? I kind of make it a habit to always use count distinct with the primary key. Just because that way I know, like, I'm not gonna, like, let's say for whatever reason, I did a join to actor, right? So if I were to say inner join film actor A on, I guess now I gotta put F in here. So like if all of a sudden now I'm doing a join, so like let's say my data set also has actors in it. Because like maybe I want a count of all my actors and a count of whatever. We would do this, and if I were to use, so like right now I'm getting hopefully the same results, but if I were to take out this distinct, so our G right now is 177. So yeah, that changes to 976. So that's why I get in a habit of, whenever I'm wanting to count like individual things, like unique movies, I always do count distinct with a unique key, which in this case is the film's primary key. So we know it's unique, and that way we're safe. We're going to count unique films, because then we can do things like this. Oh, how many actors, how many unique actors? Case when rating is equal to G, then fa.actor ID. So now, from the same result set, instead of counting the film ID, I'm going to count the actor ID. And because we joined it, all the actors that are in G-rated films are now going to be in here. Now, these actors may appear in a G-rated film and a PG film, but as far as like if they were in 3 different G-rated movies, we're only going to count them once. So, we had 199 actors in 177 G-rated movies. But that's why I use a count distinct. All right, question 3. Yes, this is the tricky one. Write a query that returns the alphabetized letter of the customer's last name and the count of the active and inactive customers. Got it. Okay. All right, cool. Yeah. So this first one's not necessarily the easy one, but it's the easier of the two. So what we're going to do is we are just going to, basically what it wants is it wants the first letter of everyone's last name and how many people in the active column have that last name and how many are inactive. So let's start. I kind of like to layer. That's I kind of really like about the SQL language is we can really layer things. So what I always like to do is I always like to kind of just start and say like, oh, what data? Before I do any counting or aggregation, let me just pull the data. So we're first going to start with customer last name and whether they're active or not. Is it active flag?
No, it's just active.
I guess I need my alias. There we go. Okay, so I like to kind of start with this and then let's order by last name. Here we go. So I kind of like to start with this because then we kind of just know what we're getting at. And so the next thing I'm going to do is I'm going to tease out that first letter of their last name. And I can do this with a substring function. So I'm just going to use c.last name. And we're going to go one character, start at the first, go one character long as, let's just call it letter. There we go. And check my results. Looks good. So now I kind of have my base. So I'm just going to take and copy this because I have a feeling we'll need it for the next question because I went and looked ahead. So now what we want to do is we can take out our last name here because we know we don't need it. So we're just going to have a letter and we're going to take out this because we want to count things. So what we're going to do is we're going to now say, oh, we want to know how many per each letter. So we want to count. And again, I'm going to use my distinct and we're going to say case. Let's just start with our total. Let's just start with c.customer ID as total. And because we're doing aggregation, if we were to run this now and you have the proper mode set, it's going to fail because we need a group by. Because we need to tell it what we want to group this by, and I'm going to group it by the letter of their last name. And sometimes it doesn't like it. So if you ever have a problem with these functions, it doesn't like the alias, you can just throw the whole function in there and that should work. Oh, that's why. Order by is what it's complaining about. So let's go back to letter and we're just going to order by letter. There we go. So now we have our totals. Now we want to split it out because we know we're like aggregating, right? So now let's split it out. So now let's count distinct. And this is where we're actually going to get into this week's stuff. So we're going to say case when c.customer ID is c.customer ID, c.active is equal to 1, then c.customer ID end as active. There we go. And so now we're just going to add our comma to this, look for the other version of that, give it a new name. There we go. We can make sure we total out because that's important. We want to make sure that the inactive and active ties out to the total. In this case, it looks like it is. So we're good. So that is question 3. Does that make sense?
Yeah, that's awesome. I was really overcomplicating it.
Yeah, that's easy to do. Very easy to do. Now, this next one, we are going to get just a little bit complicated with. And I am a huge fan of Visual Studio Code for reasons just like this, because and this is actually fun. This is where we get into like data fabrication, which I think is really fun for some reason. So what I'm going to do is I'm just going to turn on my caps lock. And I'm just going to do A, B, C, D, E, F, G. There we go. So just type that out. And then what's nice is I can just look for a space. And what we're going to do, and actually I'm going to cheat just a little bit more. We're going to do one more. We're going to look for the space. And what we're going to do is we're going to say select. And let's actually put a return at the beginning. So that'll get us that far. And now what I want to do is I want to look for a carriage return. And we are going to replace that with a carriage question mark as letter union. And then another carriage return, just like that. Then we can just get rid of this extra one up here. And there we go. So now, like if we want to test this, we should just end up with every letter of the alphabet, which is pretty cool. So from here, what we can do is we can do a couple of things. What I always like to do is I like to, and we'll get to this in the last weeks of the course, but we'll cheat just a little bit because it will help. Now, you could just throw this in and make this work. And in fact, let's do that real quick. So we're going to use our same query here. But what we're going to do is we're going to do a join because we want every letter. So if we go look at this question 4, is there a question 5? There is. So if we look at question 4, it wants the same thing, but you'll notice that there's some letters of the alphabet that don't have any names like Z. And in our previous result set, because we didn't have any customers with the last letter Z, we just didn't have that section. So if we want to see that, basically we have to come up with every possible combination of letter from somewhere, which is just what we did. We kind of just like built our own. So what we're going to do is instead of saying from customer C, we're going to say from, we're going to put our subquery in here. I guess I need to copy it again. So we have all of our letters here, and this is really long, which is why we're going to show a shortcut here in a minute. So there's all of our letters, and we're going to call this alpha. We're going to left join that to customer C on alpha dot letter equals C dot. And really this is where we need our first name. I don't think letter works there, so we have to use the actual substring here. And here, instead of saying substring, we're going to say alpha dot letter as letter. And now we have our entire result set. And that's because we're starting with all of our letters. So we start with the alphabet and we assign customers to that based on the first letter of their last name. So ultimately, same thing, but this time we have all the letters. So in the cases where there are no customers like Z and X, we still have those in our result set, but now it just shows 0 on all of them. So now for the shortcut, if we wanted to make this a little bit easier, so we have our big giant select statement that we could use as a subquery. If we knew we were going to use this frequently, which, you know, it's always kind of handy to keep some of this data around, we could say create table alphabet as, and hit that, and it will create the table. Oh, and I actually already have one. So let's drop it. Drop table. And then create the new one. There we go. So now we can select everything from alphabet. And there we go. So now we have a table. The other thing you could do is you could say create or replace view. This is what we're gonna talk about the last week of the class, actually. And I always preface mine with v underscore. So v underscore alphabet as. And what this will let us do is it actually just saves the query. So I can actually just say select everything from v underscore alphabet. And alpha, what did I spell wrong?
You typed it with a V up top as well.
Got it. Yes, I did. There. Go. So now we have our alphabet. So then what we can do is instead of having this subquery, even though the query is still running, we can just say v underscore alphabet alpha. Now it makes it a little shorter. And what's cool is, so like, let me refresh my list here. But inside of my views now, I have this, I actually have both of them. So let's delete this one. Drop that view. So we have our view here. I can actually go in here and see the actual query that runs this. So this is defined now. Basically, a view is just like a saved select statement that we can reuse as if it were a table. So that's why I kind of like the views, because it's not going to take up any storage on our database. It just runs that query, basically like a little safe query that acts like a table. So you can do any of the three. I'll take any of the three. All right, that's question 4. And question 5. Okay, so the other part, so this one, basically we want the same thing, but this time we only want the letters where the active customers is greater than 30. So this is actually going back to our aggregation, but most of the time, so we know from our queries that we have like, you know, select from, and our from includes our joins. Then we have a where clause. Now I can't say where active is greater than or equal to 30 here. It fails. Because active in customer is, well, and it just wouldn't work. So basically what we're going to do is we use our having clause, having active that is greater than or equal to 30. And there we go. The having clause is basically a filter. So the having clause is a filter for any aggregation. So if you want to filter something after it's been aggregated, you have to use the having clause, because if you use the where clause, it hasn't been aggregated yet, because the from clause runs first, followed by the where clause. And so at that point, it doesn't even know about all this stuff or the group by. So the having clause is kind of the trick to that one. And that's question 5. So I guess if you're hear or watch this later, the exercises should be pretty easy this week. But hopefully it helps make sense of it. Does anyone have any like fuzziness around anything here that we did?
No, it looked awesome. Thank you so much.
Yeah, no problem. No problem. Just a quick word. If you're doing a final project, we are nearing like the point where, we should start to be kind of like putting stuff together a little bit. We're on week 10, and they're due week 13. So it's a little crazy, only 3 more weeks. So what we're going to do is next week we're going to kind of cover some more final project stuff. Because I've gotten a few more questions about like test cases, and the like. So we're going to be talking about that, in addition to transactions. So if you're doing the final project, make sure you're there next week. Transactions are really cool too. So yeah, we'll be covering that and some test cases and stuff next week. And I'm hoping next week to cover. I actually want to do a quick, I'm going to try and put one together, a demo of just like a simple PHP like file that you can run on your computer that'll pull against your Sequila database, to kind of give you an idea of like kind of how that works. So we may cover that as well. But anyways, if no one else has any other questions, I told you to be short and I lied because it's been almost 40 minutes. So, but hopefully it was effective and good bang for your buck. But anyways, it won't keep you any longer. Have a good evening. If you have any questions, just stick around and we can answer them.
Thank you very much.